the plant, the central heating and cooling plant, has these large electric chillers that are making cold water, and then that cold water is distributed around campus and used by the buildings, and then returned to the chillers. So, and then how the buildings operate and use that chilled water in their building heating and ventilation systems and air conditioning systems really impacts the efficiency of the chillers. And specifically this quantity delta T, which is basically the difference in temperature between the chilled water supplied by the chiller and what returns to the chiller is very impactful on chiller efficiency. And so if buildings are not kind of using the cooling they're getting and returning back a much lower much higher temperature back to the chiller, then that impacts chiller efficiency. So essentially, exposing the data from both systems made us able to see which buildings were impacting chiller efficiency, and then ultimately see the results on chiller efficiency.
We've got some slides. We're looking at the delta T screen.
Yeah.
Now you were saying that this type of comparison was just something you weren't able to do before in the past.
Yeah, that's correct. Just having a single view of all the buildings, delta T and flow, and then how the plant is behaving as a result was not something we were able to see before. So the power really is for the plant. If the chiller is not running efficiently, the plant can then identify why. Whereas previously it was a total black box. And then that then feeds into operational collaboration, because all of a sudden there's enough information for folks to actually substantively collaborate. Whereas before it could just be like, hey, our chillers aren't running efficiently. What are you guys doing? And they might say like, we have no idea, or we have to drill in and look at the different buildings. But now it's kind of all there in a single view. And then similarly, a building operator could look at a building and see a building that's high flow, low delta T, which is kind of a energy problem, and then either fix the operations or identify a retrofit that needs to be done, or whatever it is.
Mm-hmm. Okay, right. What were the interfaces that you needed to use to get that two sets of information together? Was that both from the same control system, or were it different control systems?
So the plant control system is a Wonderware system. So we're currently using the RDBMS interface for that. We do, not that particular Wonderware control system, but a different Wonderware control system. We've actually collaborated extensively with OSIsoft to use the new Wonderware connector, the connector for Wonderware Historian. So eventually we'll also, that's for our water and gas SCADA system. Eventually we'll roll that over and use it for our central heating and cooling plant SCADA system. So we really like the connectors, and the fact that the new tags now are created automatically, and there's quite a bit of benefit there. And let's see, the building control systems are largely Siemens systems. So we've used different methods to get those into Pi, but largely we've used RDBMS and OPC at this time.
Okay.